Hello everyone and welcome to the video on how to do hypothesis testing utilizing statcrunch. Just a real quick caveat, this video does not discuss any information on the logic of hypothesis testing. I'm not going to talk about any terminology. I do have other videos for all of that I have posted in the class. This is not a replacement video for your textbook and other information, but rather I will apply some of that information. So this one particular video, I want to take a look at hypothesis testing regarding proportions. So let's go ahead and fire up some of our homework here. So let's see, come down here, assignments. And please forgive me, I just got this Mac and I'm still trying to work out a few kinks regarding this Mac. So I'd like to take a look here at this particular exercise. Okay. And here we're asked to determine a critical value for a left-tailed test regarding a population proportion where alpha is equal to 0.025. Now, this is really just nothing more than a hidden chapter 6 question or chapter 7 question on the normal distribution. So let's just do a little quick retrieval, and you may want to take some time and review finding z-scores. This is nothing more than finding a z-score given an upper-tailed, lower-tailed, or a two-tailed area. And this was an exercise you did back in chapter 7 with the normal distribution. So to find critical values, which this one's asking right here, a critical value for a left-tailed test. All right, this is nothing more than back in chapter 7 where they said, suppose that you have a left-tailed area of 0.025. What is the z-score? So to assist us, let's just go ahead and fire up statcrunch to assist us. And in this case, we just come over here to stat. We'll use our calculator and come over here to the normal distribution. All right, so the alpha area that we had, let's just note that our alpha area in this case was 0.025. So I'm going to try to parallel my windows here. Hopefully everything will work. Yep, it did. So all we have to do here is what we want to do is find the z-score. So this will be the z-score and this is the area. So if I put in 0.025, all right, which is what we have here, this is the part we want to find, and since this is a left-tailed test, I need this direction to be less than. And notice we could switch it for an upper-tailed test. All right. So now we just click compute, and for our left-tailed test, notice that we want to round to 2 decimal places. So this is a negative 1.96. So we'll go ahead and tag along the sign here. So negative 1.96. Click check answer. And there we have it. So whether you're doing this for a mean or a proportion, this is exactly what you would do to find the critical value. Okay. All right. So I'm going to close this window real quick. Close this window real quick. All right. And sorry for all the dancing here. Now I'd like to jump up to this exercise here. Number 22. All right. So this one is asking us to perform the hypothesis test for a population proportion. We're going to use the p-value approach. Okay. So let's just note that we are given a null of p equals 0.08, and we are given an alternative that p is greater than 0.08. We're given n, x, and alpha. So all we got to do is kind of fill in the blanks. So notice that the first thing this is asking us to do is to find the test statistic here. So I'd just like to just real quick pull up the textbook here and show you how statcrunch is going to kind of be a asset, if you will. It's going to be something lovely for us. So what I want to do is to pull up this real quick formula for the test statistic, and it's right here. So this guy here is what you're going to have to crunch right here. All right, so it's p hat minus p under the null hypothesis divided by the square root of p under the null, 1 minus p under the null, divided by n, the sample size. And if you can see that, maybe you're into it, but I'd like to avoid using that as much as possible. So again, let's just come over here to statcrunch. Okay, just question help, fire up our statcrunch. Again, I'd like to parallel my windows. Okay, and again, we'll come over here to stat. And in this case, proportion stats, we're going to choose one sample. And notice in this case, we are not given data, but we'll go ahead and choose the summary. So here we want the number of successes X, which in this case is 110. And we want to do the number of trials or the number of observations, N, which is 125. And then our null hypothesis, which is 0.8. We'll just make that, and notice that this one here we have to change from not equals to a greater than. So once we have that, we've got all of our dots, I's dotted, T's crossed. Click the magic button, compute, and notice that right here is our number, right here. Let's see, round to 2 decimals, so 2.24. So we'll just go ahead and plug this number in, 2.24. and click check answer. And notice that that formula I pulled up in the textbook, we didn't have to mess with it. It's right there. How lovely is that? Our p-value, again, now we'd have to compute the probability of seeing 2.24 or something as extreme, in this case, in the positive direction. But notice this has been done for us. We've already got this computed. So notice here we get a p-value of, let's see, it says round to 3, so 0.013. 0.013. Okay, let's check our answer. Well done. All right, so now we have to make a decision. So this is where that decision making regarding p-values. So recall that to make decisions with p-values, we reject the null in favor of the alternative when the p-value is smaller than the alpha level, and we fail to reject the null when the p-value is greater than or equal to the alpha level. So an easy way to remember this is reject for small, fail to reject for large. So notice now we have to compare 0.013, or if you will, 0.01 to 0.05. And notice that the p-value is smaller than the alpha level. Since the p-value is smaller than the alpha level, we will reject the null. In other words, what this is telling us is that there is sufficient evidence in the data that shows support for the alternative hypothesis. I really want to emphasize that. We're not saying that the alternative is true and the null is false. What we are saying is that the data shows support, or there's enough evidence in the data to show support for the alternative. So now since we reject the null, we have to come down here and notice that we have 2 rejects, so we can kind of cancel out the do not rejects. So we reject, we just got to pick the right reason. So reject because the p-value is less than alpha, or do we reject because the p-value is greater than alpha? And as we just said, we always reject when the p-value is smaller. So we'll go ahead and check that answer. Okay, and that will put us to the next question. So hopefully for proportions, this little video helps you out. And that's all I got for now. I will make another video for the means. Thank you.